Thank you everyone for joining our AMAs this week. This time we have a special guest as well. We're discussing security and the Move programming language. I would like to hand over the mic to our speakers, starting with our special guest. So if everyone can introduce themselves, that would be great.
Yes, I'm Robert. I help run OtterSec. We're a blockchain auditing firm. And yeah, I'm excited to talk about Move as, a language that enables more secure development.
Sam, Kostas, Joy, want to get the train rolling?
Sure, I can go next. I'm Sam. I'm the co-founder and CTO of Mysten and the creator of Move. I've been working on Move since 2018, and after joining Mysten, have been working on creating SWE and creating the particular dialect SWE Move that we're using inside of SWE that tries to be really object-centric and take the resource safety and asset centricity of Move and really bring it out into the system level as well as into the programming language. And been speaking with Robert and a bunch of other folks on security in the Move ecosystem and auditing, and excited for the conversation today. Kostas, do you want to go next?
Yeah, I'm Kostas. I'm also co-founder at Mysten and also the Chief Cryptographer. I'm coming from Facebook as well as all of our co-founders. I used to lead the cryptography team there, not only for Libra and Novi, also for WhatsApp, a few things. And I'm in the space for a long time. My expertise is actually some cool algorithms for blockchains that you will hear today, and also how to attack the systems and how to protect them. Joy, for next.
Hello, my name is Joy. I'm a software engineer at Mysten. I work on the cryptography team. Lately, been working on our cryptography libraries and making sure that the foundation for the SWE network is secure and good to go.
Perfect. So just to give context for people dialing in, we are doing a simulcast on both our Discord server as well as here on Twitter Spaces. We have our lovely mod team that will be monitoring both channels. So if you didn't have the chance to submit questions prior to this, please do submit them. Now both our event chat is ready, and we're also monitoring our @replies and inboxes in case you have questions that pop up throughout the AMAs. Now to dive straight in, we know that not everyone may have a clear idea around security, specifically some of the things that you do, Robert. I think for clarity, maybe you can dive into what does a typical audit include, and does the Move programming language actually make it easier?
I think it enables you to write structurally safer code. So one example of that would be everything is well typed at the runtime level. Or, the bytecode is well typed. You can't have any sort of type confusion attack, which is like a common problem you see on other blockchains such as Solana. It also has a lot of really cool features like the Move Prover, which lets you formally verify assumptions about your program, which is like really helpful if you're trying to, prove, for example, that a swap doesn't give you more coins than you put in. I think that's kind of my general thoughts on that.
So going along with that, when should Move developers be ready for an audit, and what is the typical duration of audits?
Yeah, that's a really good question. I think our recommendation is always prior to mainnet launch. So ideally, before you go on-chain, you would have some external third party who is reasonably versed in security take a second look at it. The reason being is you don't want production assets getting stolen in the case of a development flaw. I think in practice, that might be a bit difficult, but yeah, there's like a lot of backlog with these audit firms, right? Because everyone needs an audit at some point prior to their launch. So I think, if you're building a project, it might make sense to start reaching out earlier rather than later, just to make sure you're scheduled in.
We had some additional questions in regards, it's Move related, but it's actually closer to fast crypto and how people may think about security inside the SWE system itself. Maybe one of the things that we can consider, question for actually the entire panel, is, how do we think about libraries and dependencies, and how do we audit them for our system?
Yeah, actually, this is like a really interesting question because we've been thinking about this actually a lot, because as we're auditing code right now on these rapidly developing ecosystems, one concern is that while we audit it at this commit hash, it'll look good. There might be like some feature change later on down the line that breaks some underlying assumption and then causes like the protocol to lose money. And I think this is actually like a very difficult problem, right? So one example of this would be the actual SDK code, which pre-mainnet is rapidly evolving. The issue is as we're doing audits, we do them on a fixed point in time. We don't constantly monitor the changes to these SDKs to see if they actually affect the protocol. So I'm actually not really sure, what the best way to deal with this other than to like re-audit your code just before mainnet when everything should be finalized. But I'm curious to hear what other people's thoughts on this are.
Yeah, I think that's always the best practices that are hard to recommend against. I do think if you're using something like the Move Prover and you put a lot of effort into specifying all the things that are important about your particular contract or application, and then you have the auditors take a very careful look at the specifications and make sure that this is saying everything that you need to say about the code, and it sort of captures all the behavior. And then you make some changes and continue running the prover, and the prover says your code continues to satisfy the specification. That's a pretty good guarantee that things are about as safe as they were at the time you had the audit. Of course, I wouldn't say that's nearly as good as just doing the audit at the last second, but I think that is a little bit better than just looking at the code at a point in time and then making arbitrary changes and saying, oh, it passes the same test or does the same thing. Using the prover does give you this level of exhaustiveness that's difficult to get otherwise, which I think is potentially interesting.
I can also add a few things, especially for the cryptography part. One of the operations that we actually followed was to distinguish and actually decouple some of the main components in different crates in Rust or in different libraries. So it's even easier for us first to review, second, even for the auditor, right? Imagine you're having a huge stack with so many things, consensus, move language, cryptography. There might be some other operations internally, like for key management and so on. So one of the approaches that we followed, let's split them in like distinct libraries where like maintenance is easier, at least for the auditor's perspective. And then we can actually have like, especially for the crypto part, what we did is we have all of the dependencies in this particular algorithm, and the SWI and the move protocol is actually only having a dependency on our own fast crypto library, which makes all of the evolution much easier for us. And it helped a lot. Originally, we didn't have it like this, and eventually we decided that this is the best approach. Even at DM, when we were at Facebook, there were like a whole monolithic approach, even if there were like internal crates. It was much more difficult to point some people to, hey, go download this particular crate and work with your audit. While here, I think we made the life easier for the auditor, at least for some components that are easily separatable.
One thing to add is that we also tried to use the existing testing frameworks that are very valuable to audit ourselves, that we can, discover issues within our library now that they're sitting in one place. Particularly, we've been doing prop tests where we fuzz input and then see kind of how our libraries respond to arbitrary input, and being able to use the most up-to-date edge cases and all the testing in place, we're able to test our libraries a lot quicker.
And the final outcome out of this is we even found some optimizations, even on the security side, that will actually affect the whole community. For example, I can give you a very simple case where most of the batch verification and signatures across all of the blockchains, most of the blockchains are usually returning true if there is an empty input. And then we realized, this can be exploited if you're not careful, right? So in practice, by doing all of this work and what Joy mentioned with extensive tests, prop tests, fast tests, and anything else, we really realized a few issues that existed in previous blockchains. So we got a lesson, and we're actually building under this mentality now.
I think there's also something about how on-chain dependencies are upgraded, right? I remember asking about this a while back, so I'm not sure if it's changed, but I believe the policy was that if you wanted to upgrade, you would need to deploy a new version of the contract or some sort of versioning of the contract, which means that when you're deploying on-chain, ideally, your dependencies would not be able to change underneath you. Yeah, someone should correct me if I'm wrong.
Yeah, we're still working on that upgrade story, but basically what you said is what we're thinking about, that when you publish a contract the first time, you get a special object called or this is what we're thinking, you get a special object called an upgrade capability that gives you permission to publish a new version of the module that basically has the module privileges of the old version. Like it can still pack the same types, unpack the same types, read the same fields, and all of these sorts of things. It can also declare new functions, declare new types, but it can't delete old public functions or delete existing types or change the schema of existing types. And so what this lets someone do is you have a game, you want to add some new functionality to it, but continue using the types from your old game without asking folks to convert from type v1 to type v2. You can publish a new version of the contract that adds a new logic, and it'll keep working with the old types. And it's just, if folks want to call this code, the game code, from a transaction, they have to use the new version of the contract, or if there are existing contracts that depend on the game code, they have to explicitly opt in to using the new version. And of course, if new code is published, then it should use the new version. So this gives you a sort of mix of, you never have dependent code changing from under your feet, because that's quite scary, but also you aren't just stuck in a world where you have only immutable code and there's nothing that you can change. So we're still working on this, but that's the sort of goal that we're aiming toward, and we'll see if we can make it work from a tech perspective.
Yeah, I think that's really cool. I guess, how do you think this functions with respect to patches, right? If you deploy a contract and you have $100 million of TVL locked in there, for example, and then you find some issue that you want to patch. If you need to deploy a new contract, I feel like it might be an issue to migrate all that liquidity over, or you need to do something. You either need to have an upgrade function already built in, or you need to tell all your users to withdraw from the old version and migrate to the new one. It seems potentially Yeah, I'm not sure, like, have you thought through that user story before?
Yeah, so I think the proposed scheme would work for that use case. Like, let's say you have a DEX and there's an off by one error in the DEX somewhere, it's in one of the functions. And so your DEX isn't actually the contract, what it is a shared object whose schema is defined by the original module. And so what you would do is you would publish an upgraded module that fixes the off by one error, but it's still, that shared object is still type compatible with the new code. The money doesn't have to be moved over. Folks who have positions in the DEX or other tokens interact with it will still work. It's just if they don't want to deal with the off by one error, as they shouldn't, then they should use the new code instead of the old one. There's still things you might have to do there. Like if this is an exploit and you want to prevent an attacker from using the old version of the bug, then you probably want to set up your code to have a kill switch that stops you from using the old functions and forces you to use the latest version. But in general, this should prevent you from having to do a migration in that case, unless the migration requires a new schema for your objects. Then you'll always need to change things.
So I realized I kind of got ahead of myself with some of the questions because I realized that actually you've published Fast Crypto, I believe yesterday. What is it exactly? Just for the audience and myself to be better informed about this.
Yeah, sure. So basically, I think Kostas covered kind of the why behind why we need a common library for all the softwares developed at Mysten Labs. And like cryptography is used in our consensus mechanism. It's called Narwhal. And we also have SWE where all the validators need to verify signatures, and also the user wallets that signs signatures also lives in a different repository. So to be able to have this independent crate very early on in our system is super important to have one centralized place where we can interact with the same interface. Yeah, and some of the important aspect there is that we have this common trait for all the cryptographic materials, and then we have all the signature schemes that we would like to support to implement the same interface. And this really helps us not only to make sure that being able to benchmark the performance and being able to find out what is the best library in the domain, and also allow us to extend the libraries with features such as testing and serialization and kind of iterate on top of that. And then we kind of describe specifically how we implement the trait with different signature schemes. And a lot of them are compliant to specifications that are very standardized. And also we deprecate the libraries that are vulnerable to some known attacks. Yeah, and then that's kind of the ideas behind it. And then in addition, we also have a lot of utility functions that are very important for our users to be able to leverage those on the smart contract in Move. We write them as native functions. For example, you can recover a public key out of a SecP 256K1 signature very easily on the Move smart contract. Yeah, and then we're able to use this fast crypto in SWE and Narwhal that allow us to switch signature schemes really quickly by just one flag.
I could also add a small point here that a few partners were also requesting for a common library that they might actually inject to their HSM or somewhere else, and they needed like the minimum possible dependencies. So it made sense actually to extract the fast crypto, anything related to cryptography outside SWE. And apart from the fact that we're using it in two different products like SWE, the blockchain, and Narwhal and Task and Pulsar, we can stay and live on its own. Also, some partners are going to use it, and we already see like use of like forks and starts from different people outside the Mysten family.
I think another question, you've touched on it, but I'd be really curious to know, it's what about the key management and cryptography support overall in SWE, if you can help summarize it, because I think I'm noticing a lot of new callers, or rather new listeners who've dialed in, both on the Discord side as well as here on Twitter Spaces.
I can take this one. So one of the things that we realized when some of us used to work for other like blockchain companies is eventually you end up into a situation where there are many partners out there. Some of them are more conservative, some of them are more modern. And then we said, okay, we extended DM, right? We built a better system than Libra, and we believe it's like more parallelizable. At the same time, we want to improve over UX and UI. And yes, we're using one of the modern versions of ECDSA, which is called EDDSA. And then we say, okay, why not also support the Ethereum smart contract algorithm? So the ECDSA K1 that is used on Bitcoin and Ethereum, which will make SWE more compatible with the existing infrastructures on key management. And then we ended up into a situation where we're super agile. So at the moment we support two schemes. One can use either EDDSA or they can use the Ethereum algorithm. They can also do EC Recover, and this will enable, for example, a lot of bridging technology to be built on SWE like seamlessly. And at the same time, we have different schemes for the validators because, for example, we're like signing a lot on the validator side and we need to compress signature. Imagine we're like proof of stake system where you need to accumulate multiple signatures from the validators and ideally you want to compress them. And there we're using BLS. So a nice thing you can see on Fast Crypto is someone can even take it, even if they're not dealing with blockchains. They can take the Fast Crypto thing. They can play with the algorithms that we support at the moment. They can even see their range proof and bullet proofs. They can even see comparisons and benchmarks between all of this stuff. And this actually helped us to make the selection of the final algorithms that will cross the line and will be applicable for SUI. Eventually, and this is important, we're going to augment this. And we even have plans to eventually allow even algorithms where your mobile phone can actually be used as an enclave. You don't even need mnemonics eventually if we support the algorithms that iPhone and high-end devices like the new Android devices support. So you will see a lot of new features there, and most of them will be absorbed and included on SUI.
Cool. Going along with this, we noticed that you recently merged PRs with builder proofs for zero knowledge proofs. So why and what's the roadmap around that?
So the bulletproof requirement was because we want SUI to have one of the richest APIs at the moment in the industry. So we have so many functionality now. You can even do like elliptic curve operations, like adding points of a particular group. We're using Ristretto there. You can even do like Pedersen commitments. You can even do now, as you said, bulletproof. So we literally have support now for at least like a type of zero knowledge proofs in SUI. It's not only for confidential transactions where this is like probably one of the applications someone would think of, which means that you can hide amounts. It's also, you can now build very interesting voting applications. You can build KYC systems in SUI. You can build auctions, sealed bid auctions, for example. You can even do encryption on SUI. And for example, using fraud proofs, you can actually have some assurances and proofs that what I'm sending you is the expected value you want to read. And if something wrong happens, then eventually we're going to have support for these operations to challenge me. Oh, I bought this NFT, but when I decrypted it, it wasn't the one that I expected. So I can challenge you and then I want to get refunded. So our vision is literally to have at the core level of SUI, one of the richest, if not the richest API possible. So we don't rely necessarily on third parties come and building like some of the basic operations. We can control better. We have a distinct team working on the quality and the security of this API functionality. And we literally expect that it will attract part of Ethereum developers or other blockchain developers because it will be super easy to build in Move plus crypto APIs, something which is more modern and requires some extra privacy functionality in the blockchain.
So moving into Move, this question actually, Robert, Sam, you might have a bit of insight as well. Doesn't Move have formal verification for safety and security? Why is auditing and checking these even required? That's some of the questions that we've received quite often.
I mean, I think my answer is going to be that, you always need auditing, right? I have a little bit of ulterior incentives for that. But I guess more seriously, I mean, I think formal verification is a tool, right? It enables you to provably know certain properties about your code. But I think the hard part is coming up what properties you want to verify. For example, if you have a lending protocol, it might not be immediately obvious how you even go around formally defining what a lending protocol is, right? Like you have withdrawals, you have borrows, you have deposits, but how do you formalize those interactions? And how do you come up with a definition of what a lending protocol should actually do? I guess some ideas here might be, for example, that the lending protocol is always fully collateralized in the absence of a liquidation event or in the absence of like large price movements, right? So that could be an invariant which would that you prove a property about the lending protocol, but at the same time, it doesn't define the protocol, right? It's unclear whether or not, these specifications that you write actually sum up to equal a fully defined protocol that you'd be confident about. And it's entirely possible that you'd forget to define something, in which case your protocol could be, vulnerable to some sort of exploit as well.
Yeah, I totally agree with Robert. I mean, to sort of draw a high-level metaphor, I think writing a program is like you're a painter that's trying to create a great painting. Like what tools can do for you is that, they can give you a very fine-grained paintbrush that can make tiny strokes instead of like a big old paintbrush meant to paint a house. And this can help, but it's still up to you to decide what kind of painting you're trying to do. What are the things that you care about? What are you focusing on in your craft? And then an auditor in that equation is like a good artist friend who's very honest with you, or an art critic or something. And like both of those can help you a lot. But like at the end of the day, like the task of programming is hard. Like defining a useful program, defining a safe program, deciding what safety means, and tools can help you a lot with that. Auditors can help you with that. But this is still a fundamentally hard thing that requires a lot of human creativity and a lot of input. So I think think we try to do as much as we can for you there, but I don't want to overstate what either a language, formal verification, or an auditor can do for you. There's still a lot that you need to do as the programmer as well.
Actually, we've been looking into formal verification a lot. I mean, I personally think that the Move Prover is a really well-written piece of software. And I think it's like really, really cool. So I've been like looking into the internals a lot. And I guess one thing that I would also point out to people who are thinking about using this is that it's quite non-trivial to get it to actually prove stuff, especially anything more complicated. So for example, with loops, the way the Move Prover handles that right now is you have a base case, or you write an invariant, and then it proves it by translating that into a base case and an inductive step, and then it proves the loop for you that way. But it's often we found that for non-trivial loops, it's very hard to construct this loop invariant, and it can be very time-consuming. And also for larger programs, it can be very difficult to get the Move Prover to conclude anything, which isn't a problem with the Move Prover. I'd say it's more a problem with the underlying Boogie Prover in that it's like it fails to converge. But yeah, I mean, I don't know too much about the state of development on these aspects, but I mean, I'd say there's definitely caveats to it.
Oh, yeah. I used to do research in program verification and static analysis before I started dabbling in language design and blockchain. But loop invariant inference and static analysis research is like this classically hard problem. It's as hard as the halting problem and harder. Like there's probably hundreds of papers written on ways to do this, like and specialized for different kinds of invariants that you want to look at. And the basic thing is that a lot of approaches just ask humans to write them because it's so hard to get good loop invariants. And sometimes you can infer basic ones, but I think this is one where, it's probably not a simple item to fix on the prover roadmap, but just something that is always going to be a little bit difficult. I think I can get better there, but deciding like a loop invariant that is nice and tight and that is easy to generalize to the other properties you want to prove is just one of those things that you as the painter or program writer sometimes have to supply. The tools can help, but the stuff is hard.
Yeah, I guess I kind of have a question too, Sam, then. Has the Move Prover been applied to reasonably complex piece of code before? Or I guess like when we were trying to use the Move Prover, it seemed very difficult, especially when you're dealing, for example, with like nested numerical classes in a swap or lending market. It seems very difficult for that to actually converge. I guess the example would be, let's say you have AMM where you define like U256 over the token values, and then you do the X times Y over 1 plus X or whatever to calculate the out amount. Like, has there been an example of that converging?
Yeah, so I'll tell you about the most complex code we've used with the Move Prover. So this was developed as part of DM, and I think we had about 15,000 lines of Move code that were implementing the DM framework. Most of what that code was doing was stuff to do with compliance, stuff to do with access control, and sort of like treasury setup. So that had a lot of specs written in it, and we got the Prover to run all those, and there's a lot of development work done to both refine those specifications, get them to pass to the Prover, and all of this sort of thing. Those specs were, for the most part, not very numerical. It was a lot about access control. It was a lot about saying, like, if you have this resource, then it means this predicate elsewhere in the program is true, and that's an invariant and these sorts of things. There have been some examples of numerical reasoning done with the prover, but I think it hasn't been as well tested on types of code like some of what we did in DM. And this type of thing is definitely something that can be fixed. Like SMT solvers are very good at this sort of thing. Boogie is good at this sort of thing. It's just about doing some engineering work to get that working, and then also just like writing your code in a way that is going to make these tools happy. I think like it's expected that this is hard, but some of the hardness there is fundamental, and some of it's going to be things that can be improved with the tool.
And I know I'm totally jumping across multiple questions. I definitely should have organized it a bit more. So to the audiences, if it seems a bit disparate, apologies, but we're getting back on track, hopefully. And to the speakers as well, please feel free to jump in and direct this, if you will. You've all been really great in terms of contributing, but also asking each other questions and making this much more of a conversation and less of a Q&A, which I think the audience also really appreciates. Can you explain a little bit more about any measures, if there are any, for secure bridging?
That's a good question. I think Jump actually did a piece on this. I think one measure would be the number of entities that need to be compromised in order to affect a message, right? So for example, if you have multiple signatures on a message, then you would take that number of signatures, like whatever the signature threshold is. But I mean, I think it also depends a lot on your threat model. So what kind of threats you believe are likely to happen versus what kinds of threats you don't really care about. So for example, layer 0, they use a different approach from Wormhole where they have a relayer and an oracle, and their threat model is that if both of these are compromised, then you're completely screwed. But it's on the user to trust the relayer and the oracle. While Wormhole's is like, oh, we have a semi-centralized set of guardians that they'll look at your messages and they'll pass them along and they'll sign them. But the threat model there is, I think it was 7 out of 13. I believe there's 13 guardians, but if like more than half of the guardians are compromised, then you're also screwed. But yeah, I mean, I think it's a pretty qualitative measure, actually. I mean, a lot of these things are like very black swan events, so they're hard to know if they will actually happen in practice. So you can make mitigations and you can theorize about what might be a more secure system, but in reality, I feel like it's pretty difficult to actually know, even for us, who are reasonably involved in security.
Yeah, and Robert's answer was mostly about protocol security, which is, of course, where everything starts. If the protocol is not safe, you definitely can't have a safe implementation of it. I think one of the really tricky parts about bridge security is that some of these expensive exploits occur in both areas. Sometimes the protocol is insecure, sometimes it's secure, but there's a software bug, either in a smart contract that's implementing part of the bridge, maybe in the relayer component, maybe there's something that allows messages to be replayed when they ought not to be. So in addition to being really careful with the protocol design and thinking about the fundamentals of how many entities you have to compromise, like if there's one component in your system you want audited and audited multiple times, like it should be the bridge. Work with auditors who are used to looking at these things, maybe use different ones for the smart contracts part versus the relayer part, because there may be different specialties or different languages involved there. You can't put enough effort into making sure that the implementation matches the spec in the protocol here.
What about like L1 security? I mean, like bridges are inherently dependent. Actually, I guess for context, I've been having this conversation with a couple bridges, but bridges are assuming a lot of stuff about the L1, right? They assume that the L1 tells them that confirmation is correct, that the L1 like tokens are modeled correctly. What happens if the L1 gets compromised? Like if there's hypothetically a relatively complex virtual machine like Move, for example, where it might be, or I mean, at least to me, it's not obvious that it is correctly designed, or it is not obvious that it is 100% free of vulnerabilities.
Yeah, I'm not aware of any actual bridge hacks that came from the underlying L1 being compromised, but this is certainly something that bridge providers think about. Like I know Axler, for example, has mechanisms in their relayer to basically, they connect to a bunch of different chains that all go through the relayer. And if there's either a smart contract bug or a bug in the L1 or some other issue on one of the chains, they have mechanisms to seal off that chain and protect the other chains they bridge to from the contagion. But I think this is one of those things where it's like, what happens when BFD assumptions are violated? Things tend to go very wrong, and you need to think of that as part of your threat model, but it's not something you hope to see.
Yeah, I mean, maybe like L1 vulnerabilities, but I'd say that it seems reasonable to me that there would be certain assumptions about the L1 that might be validated, right? So for example, we recently worked with a bridge on Near, and Near's execution model is entirely asynchronous, and that is very foreign to certain protocol developers who come from a more synchronous landscape, right? And there was a lot of asynchronous issues with regard to that bridge design. So, I mean, yeah, I guess that's an example of where it's not really a vulnerability in the L1, but it's just like there might be L1 specific things which would cause the bridge to become compromised, which would mean that there could be, a potential loss of assets elsewhere, spreading, as you called it, the contagion.
So Robert, I have a question for you. What can a smart contract developer, and in particular a Mood developer, do to get the most out of an audit? Like when you get the email in your inbox, well, I'm sure there's some meetings, then you have a conversation, but like on day one, when you actually start looking at the project, what's the thing that you would most like this to see? How can they really make sure that they can get the most out of OtterSec or whatever other auditor they're using?
Yeah, that's a really good question. Actually, one thing that we care strongly about is how clean the code is. So I think one thing to remember is that auditors are, humans after all, and they are normal people reading your code. So if your code is messy, it's more likely that they're going to miss something. And on the flip side, if your code is, reasonably clean, well documented, it doesn't have to be perfect, but, you should try to help the auditor along. I think also having a strong test suite is usually a good indicator. At least that's something that we look a lot for when we're taking on clients. I think, having a strong test suite is often a good indicator for whether or not they actually care about security. And I mean, at least for us, we prefer to work with clients who actually, do care about this stuff so that when we finish the audit, we have at least some certainty that the client is going to take these findings and then use them effectively and actually integrate them into the protocol, as opposed to getting it as a rubber stamp and then deploying directly on mainnet. Yeah, I mean, just clean code, well documented. And I guess you should read our blog and then see the security patterns and apply them potentially. I guess we don't have that much stuff on Move right now, but we'll probably start publishing some more content.
And if the developer is using something like the prover, would you like them to write the specs and then explain what they mean in English, or would writing the specs be something that your auditors would do as part of looking at a particular piece of code? Or what are the different modes you could imagine that being used?
Yeah, I mean, I think if clients started writing their own specs, we would fall in love. That'd be awesome. If we could, look at a code base, just look at the specs and be like, hey, yeah, these specs are comprehensive, or hey, you might need to add the spec here, but overall it looks pretty solid. I think in practice, most people are shipping pretty fast in mainnet right now. At least that's what we're seeing. So we've been helping clients, write out specs, giving them recommendations for what to write out further, or even like writing out simple specs for them outright. Yeah, I mean, if you have the bandwidth, I feel like using formal verification effectively and using Move as a language to its fullest is a really great idea, and it really decreases the effort that we need to put in, and also, I guess, would decrease the cost for you.
And I think we have another question. Would be interesting to get all of your takes on it, actually. What's your view about the Slope wallet attack that affected all the wallets?
One of the issues that we realize is happening here is people are moving their keys from one wallet to the other. And then obviously The weakest point is the weakest wallet that you have used in the past. And in this particular case, what can you do, right? You have the UX. At the same time, you don't want your users to be locked in one particular wallet if they want to change. So you need a way to actually switch wallets. But at the same time, you need to ensure that all of the wallets are properly audited, at least the ones that are popular, in order to at least provide some security regarding the key loss. Something that was also obvious from the discussions is because originally, in this particular case, Phantom was closed source, it was very, very difficult for people because they realized the problem there originally. Very difficult to figure out what the problem was. So ideally, we want some type of like clarity and transparency here on how at least the key management part of a wallet works, because otherwise it would be super difficult to debug, or someone, I don't know, maybe the auditing company who has access to the private code, of course, but nobody else can do it. So another thing that we should actually be promoting or figuring out how to enforce it is figuring out how we can find better methods for key management. For example, there are solutions out there who are using multi-party computations where the key, losing one key in one place might not actually compromise your account. There are cases where people are using the enclaves of their devices as an extra two-factor authenticator. And in my opinion, we should actually move towards like more modern solutions here in order to avoid, even especially on browser wallets where you can have like an operating system attack, a malware that can somehow bypass the sandbox, or like having some software that can track your keystrokes. We have to be super careful with many wallets, and I think we have to prefer like wallets that have been audited like rigorously. I know Robert is in this industry anyway, and eventually there should be some classification of like transparency on how often a wallet has been audited, and like the continuous auditing. Imagine there might be a logging mechanism that you add to the wallet, and this logging mechanism is actually exposing the key. And then if the audit happened 1 month before the logging mechanism, then nobody knows, the new update didn't have like a proper audit. So I think even auditing companies along with the wallet providers should work together into defining like the best strategy on each update should actually be audited before it's published.
Yeah. Okay. I guess for context, we worked with Solana Foundation to look into both Slope and Phantom. So we worked pretty closely with Solana, and then as a result, they got us to work with these two wallets to kind of try to figure out what actually happened. I would say Kostas made a couple of interesting points. I guess one is that I'm not actually sure if better technology can solve this problem, or I guess like having a ledger or some sort of hardware solution would work. But I think the reason why these wallets are imported from like one wallet to another was because users wanted to be able to access the assets from multiple wallets, right? So I think this is kind of an instance where these secret keys proliferate unless there's like some sort of hardware solution. It's like very difficult to prevent users from going for the easy route, right? I think when given an option, users actually don't really care that much about security. They're just going to do whatever is easiest for them. I think, at least from our perspective, it seems like before the Slope wallet incident that there was this general lack of concern on Web 2 security when it relates to Web 3. So for example, most wallets are closed source, they don't get audited, and actually we've reported bugs to multiple wallets before, and their bug bounty programs are really, really bad. So I think overall this implies that these wallets don't have a reason to care about security. And I think that comes from the users, right? Like users, when they go to protocols, they ask them, hey, have you been audited? But when you look at a wallet, no one actually cares if it's been audited, at least previously. And to be honest, a lot of these issues, I think, aren't that hard to solve. Or, that's a pretty bold claim. But I think a lot of the wallet screw-ups, at least the ones that we were investigating, were, relatively amateur. They probably could have been solved with like a simple code review. You don't even need like a comprehensive audit. You just need someone to tell you to, track what you're logging and not log mnemonics. And I feel like this is kind of a cultural issue that needs to be fixed. Maybe like in part through pressure on like the SWE Foundation side, where you can say like, hey, if you're an official SWE wallet, you need to have some sort of code review, or it needs to come from the user side where you only use wallets that have some sort of partnership with the security firm. But yeah, at least from our side, it seems like kind of a cultural issue.
I want to make one meta point and then hand off to Joy if she has any perspectives on Slope as well. But one of the things that was interesting about this hack is that I think it highlighted the need for better incident response at the ecosystem level. There was this really scary 18 hours or so when folks were seeing that funds were starting to disappear from wallets on Solana. No one really knew what was happening. Like folks thought maybe it's a 0-day like supply chain attack in the JavaScript for a wallet. Maybe it's a quantum computer. Maybe it's a crypto 0-day. All these like crazy theories about what might be going on and sort of piecing together different reports and trying to rule out what might or might not be happening. It took a very long time to get to the bottom of it and realize, oh, actually, this was fairly mundane. There's some logged public keys and these get reused elsewhere. So I don't have a concrete suggestion for how to improve this, but I think this isn't the last time you're going to see something like this. And I think there have to, kudos to the Solana community for figuring out as quickly as they did. But I think that's something really important for any emerging or existing L1 to think about, where it's basically make sure you know how to get the relevant folks who are going to put in the effort to figure out, to get to the bottom of something like this when the root cause may not live in the walls of any single organization.
Yeah, just one more thoughts I had is how, I guess, from a wallet perspective, you're always handling a multi-chain world, whereas at Sui, we only focus on one chain, and then there's, nuances between different chains. I think, how do we kind of think about building, a common interface, or from a wallet side, and having, standards such as, Coinbase Rosetta is a good example, and having those kind of unified interface for protocols to kind of integrate with a wallet securely easily would be another kind of suggestions for the ecosystem, for the custodians and wallets providers to think about.
By the way, an interesting outcome of the slope attack is many of you might know that a month ago, before the attack, we actually, as Mysten, have published a serious API vulnerability on the EDDSA algorithm. And for a while, nobody was sleeping in our crypto team because it might be the source of attack. As Sam said, for many hours, nobody knew what was the source. I was pinged by dozens of people. Is this the attack that you figured out, or it's something else? And nobody could give an answer, right? And for me, it was very, very difficult to actually do any type of auditing if I couldn't see the code. And this is where rumors are spreading, and sometimes there is misinformation, until we learned about the real cause of the issue. It was very, very scary moments.
Yeah, actually, I guess I would like to kind of push back a little. I mean, I'm probably biased because I was partly responsible for helping out, but I mean, I think in these kinds of situations, it's actually I think Solana did comparatively quite well. I think it's very difficult at the foundation level to publish responses, because if you publish something, you need to have 99% certainty that it's accurate, right? If you publish something and then you turn around and you say, oh, actually, what we published is wrong, it was actually a different root cause, then you lose a lot of credibility. And I think, in this time of confusion, it's very difficult for them to get out accurate information in a timely manner. And I guess on their side, what was happening internally, I think within 30 minutes of them even getting news, they had pinged a bunch of audit firms to join this war room. And I think pretty early on we determined that it was not a cryptographic, or it was most likely not a cryptographic vulnerability, right? Some reasons for that was the scope of it wasn't that large. It was only affected to a certain subset of wallets, which would imply that it's not a generic cryptographic vulnerability. I think the issue is that we weren't 100% certain, so we couldn't really publish anything about it. And because we weren't certain, there was this, rumors spread, and then people had their own theories, and that was kind of the root cause of a lot of this disinformation. I guess the point I'm trying to make is I'm not actually sure if there is a really good way. I think, having people on standby with a retainer model is probably the best way that I can think about right now to address such a scenario if it did happen, especially to emerging ecosystems. But aside from that, it's it seems like a very fundamentally difficult problem to handle. And yeah, I'm not sure if there is a cleaner solution.
Yeah, that's a super interesting perspective from someone who's an insider on this. I'm probably sitting here thinking that crypto Twitter is the one figuring this out, but of course, they're not, and they're the one whose incident response is moving quite a bit slower than the real incident response. Where, as you say, they have an idea that ruled out a lot of things in 30 minutes. And I think the strategy of you get a war room with audit firms and I don't know, maybe wallets or other key folks in the ecosystem, and really focus on figuring stuff out and less on communicating stuff externally. That seems really good advice for how to handle this sort of thing. And as you said, I think Solana did do a phenomenal job given the degree of difficulty of this sort of thing. Thanks for sharing that story, Robert. That's super interesting.
So I think those were the formal questions. Going through some of the last minute that came through, I think you may have answered it in a tweet, but good for the wider listeners to also hear. This comes from Mosaic Regressor. In the past, Robert and myself have competed against each other in CTF competitions. He has also put, if you can call it competing, Robert schools me, would there be any interest in creating a Move Suite focused mini CTF in the future? He basically is saying he's thinking of working with the community to come up with a series of challenges related to Move that could be fun and interesting, but also drive learning through Move. Are there any thoughts on this?
Nothing other than that I would really love to see it. I think it would be incredibly useful.
Yeah, this sounds really fun. I would be down to contribute.
After this event, actually, we're going to prioritize it. I was personally involved at CTFs at Facebook, and I love the process, also hackathons and all of this kind of bug bounties. And yeah, thanks so much for the recommendation. Maybe we have to prioritize it a bit higher. And it's going to happen. And obviously, after testing it as well, we're going to have like more stable and rigorous systems to find very interesting questions. I will personally create a doc, by the way, and I will expect from the community to send us a few ideas on what types of challenges they're expecting. We're going to add our own. But yeah, it will be an interesting game of proposals, and then we're going to have some acceptance policy, and then do it as fast as possible. Thanks a bunch for the recommendation.
So I do want to leave a last bit of a window in case our lovely speakers wanted to have some parting comments before we close this AMA out today.
Actually, I guess we recently published, I published a piece on Move, and I have some pretty strong thoughts about Move's typing system, actually. So it's on our blog, osec.io. It's like the latest one called Move, an auditor's introduction. And if anyone wants to read it and tell me what they think about it and argue with me, that'd be really cool, because I think I have some pretty strong beliefs. So I think they're like maybe a bit out of the normal spectrum.
For the listeners, can you explain why the strong opinions?
Yeah, the argument's not like super well developed, but I think I make the argument that Move's typing system to create associations is like an anti-pattern, and it's like a proxy for the intended system, which is to create relationships with actual instances of objects. And I guess the context for this is I'm also working on a more secure framework for development on Solana, right? So I've been thinking a lot about how do we make these programming languages structurally safer, especially I guess with a touch of bias from my side, given that, we've looked at a lot of code, we're biased towards the kinds of vulnerabilities that, people tend to make. And yeah, I mean, at least from my experience, it seems like there's potentially a bit of an anti-pattern here. But yeah, I would love to argue about it on Twitter with people.
There's been a lot of good Move content from the community lately. I dropped a link to both Robert's post and a great post from K-Class, one of our community members, that goes really deep on comparing Move versus Solana development on a variety of dimensions. It's 41 pages, but well worth the read. It's a month's worth of very deep work from someone who really knows both languages and ecosystems well. So really plug in both of those posts.
Oh yeah, that one was really good too.
Any last words, Kostas, Joy?
I think we covered most of the stuff on the cryptography side. If you haven't, please check out the new crate Fast Crypto and give it a try.
Well, in that case, thank you so much, Robert, Sam, Kostas, Joy, for joining us in this AMAs. To all our listeners, thank you for being patient and also sharing some really great questions. Next week, we are actually shuffling through. Please bear in mind that our engineering team will be at an offsite on the week of the 19th. So we are figuring out how to best structure next week's AMAs and the weeks after. We'll have more information coming out shortly. But once again, thank you everybody for your time. And this is actually recorded, so it'll be available after this session closes. Thank you. Have a great day.